There we go. So we're going to take the function p of x and we're trying to evaluate it at c, at the location c, where c is -3. So we're really replacing x with -3. Okay, that's the first part there. When it says you're evaluating p of c and c is -3, it means you're really doing p of -3 like that. Well, -3 goes in here, here, and here, right? So I could just plug in. But what would that be called? What kind of substitution is that? Standard or direct. Yeah, the normal one, right, that we know? The regular way. Now, the text is asking you to do it using synthetic substitution. Okay? It said synthetic division, it said probably, right? It did say substitution? Okay, good. Some books term it as division always. So synthetic substitution tells me that if I want to plug in -3 into this, I put that outside. If I want to test -3 in the function, I want to test -3. What do I mean by test? I mean see what the y value is when I plug a -3 in for x. To do that, I need to have this in the correct order. So what do I have to do with my coefficients to put these in the right order? To list the 4 coefficients here in the correct order from highest degree to lowest degree. What would they be? 2, 3, -5, and 2. So far, so good? All right. Now, this was the thing that we did in class. We did this yesterday with the first example. I had you guys use direct substitution and plug in like 2. And then I said, all right, now divide by x minus 2. And do that also using synthetic division. And what you ended up getting here was some value right here. And it turned out that this is the y value, James. Okay? And this is the x value. Yes?
So does in this case like x equals c?
Absolutely. Because we're evaluating p of c, which is p of -3. Well, where does the -3 go in for? It goes in for x right up here, doesn't it? So it takes the place of this x. We're now looking for p of -3 because it said find p of c. C was -3. So what they're really asking you to do is say, evaluate this function when x is -3, even though it's a c. And c just means at some point c. Okay? C is what you would call a parameter, really. So this is your x value. What you get out is the y value. Well, I have a question for you. I keep asking you guys, what happens if this is 0? What happens if this is 0? What does it mean if this remainder is 0 right here? It means that -3 is a root, or a 0 of this function. Well, if it's a root or a 0, it's an x-intercept. When you have an x-intercept on a graph, I'm going to draw you a quick graph. Tell me, what's the coordinate? Oops. What's the coordinate for this x-intercept right here? What's the coordinate? 2, 0. Thank you for answering with a coordinate and not the number 2. Okay, the coordinate is 2, 0. Well, what's the y value? The y value is 0 for the x-intercept. You could see it literally right there. There's the y value. Well, didn't I tell you a minute ago when a 0 comes up here, you have one of the roots or the x-intercepts, or you can call this the 0 of the function. This y value is 0 here because the remainder is really the y value. And we're going to get into a lot of this in 8.7, and that helps to kind of help you with 8.5 a little bit, so it's kind of sucky, the timing, that we haven't gotten to 8.7 yet. But we can still get through the concept here. So if I were to go ahead and run through this table, I would start my process by bringing down the 2. Do you have this process down pat yet, James, or no? Okay.
I think I got the answer.
It's just more of understanding what it means and what you're doing with it. Yeah. So if I were to plug this through, what do you got for your numbers, James?
2, -3, 4, and -7.
Would others agree with that for this one? Yeah? So what this means is the following. Here's what this means. You have the coordinate, -3, -10. Okay, that's literally all it means. Now, in 8.7, and with Descartes' rules and that extra section we're going to work on, we're going to see that the fact that these signs alternated, see the signs? Look at the table. Look at the first row right here. Positive, negative, positive, negative. Alternating signs means something, actually. It means something. And we'll discuss what that means specifically when we get to 8.7. I don't want to inundate you with all this information because it's not really on this test yet. Okay? But what I want you to get from it is this. Ready? Jot this down. When the y value, and in parentheses you can put remainder, when the y value is 0, or when the remainder is 0, and I'm pointing to right here where I'm circling, when the remainder is 0, the x value that you tested is a 0 of the function or root of the equation or x-intercept of the graph. Again, when the y value, aka remainder, when the y value is 0, the x value you tested is a 0 of the function, meaning it causes the function to become 0. Well, that's because this is 0. That's what I'm speaking about right here. If this turns out to be 0, you call this a 0 of the function because it caused 0 to occur. That's why it's called the 0 of the function. You also know it as a root of the equation. Well, that's if the equation is set equal to 0. So it's still like a 0 of the function. So if I take the original function we had up here, instead of putting p of x, I cross this whole thing off and set it equal to 0, I'm still undergoing the same process. But now, I would probably call this negative 3 here. If it turned out to make this 0 somehow, I would probably call that negative 3 a root to the equation, because it's an equation that you now have at the top. Prior to me making that p of x 0, though, it was a function. So you would have called this a 0 of the function. But in the end, it's the same darn thing, isn't it? Okay, it's the same thing. So this is the 0 of the function, the root of the equation, or the x-intercept of the curve or of the graph of p of x. All right? Now, if this is a 0, we've said all those things, which is great, but what else do we know about factors then? If this is a 0 at the end, what do we know is a factor of this polynomial? Almost automatically this is a factor, or some multiple of this expression will be a factor. What is one of the factors of p of x now, as a result of this statement? Assuming this were, guys, imagine this came out to be 0. Just for a second, please. Imagine that came out to be 0, okay? Just make believe, I know it's not. We can make it work. What's negative 3 times 4 is going to be negative 12. Make this 12 instead, and now it's 0. It works. You see what I just did, by the way? Clearly, I'm going to do negative 3 times 4 is going to give me negative 12, plus 12 will give me 0, won't it? So I just made that a 12, just for the sake of this problem. So I make that a 12, I get 0. Well, that's great, okay? So here's one of my roots, or my x-intercepts, or the 0 of the function. So what is a factor, then, of p of x? If this is one of your roots, what must a factor be? Nobody knows this, really? Just Sarah? What must one of the factors be if negative 3 is one of the roots? M. X plus 3. Very good. X plus 3. Again, or some multiple of that. What do I mean, Chandler, by this? Some multiple of x plus 3.
Well, you can multiply x plus 3 by 2, and it'll be multiple of that.
And then what would the answer still be if you solve this one set equal to 0?
0.
No, what would x equal still?
The original function.
No, right there I'm saying. At the very bottom. Solve that bottom equation you just gave me for 0, for x.
Oh, it'd be negative 3.
Yeah. See if these both give you the same answer? Take a look. Don't they both give you the same answer? Right? So that factor that is missing or that you don't know could be x plus 3. It could be 2x plus 6. It could be 3x plus 9. It could be 4x plus 12. Any multiple of the factor in its most basic binomial form. Now, how do I know for sure or for certainty that this is one of the factors actually and not this? How do I know that x plus 3 is definitely a factor and not 2x plus 6? Yeah, but it could still be a factor. You would just factor out of 2. It'd be 2, parentheses, x plus 3.
Because one of the factors factors is 2x squared minus 3x plus 4. So then the other factor can't have like a number 2 in it, because then that would make the first value 4.
Yeah, go back to the original function. What was the leading coefficient? Look at the top. What's the leading coefficient? What is it? It's 2, right? You got lucky if you guessed this too, by the way. You got very lucky. It's 2 from right here. This is the leading coefficient. It's the coefficient for the highest ordered term. So 2 is the leading coefficient. So as Chandler mentioned, take a look at your synthetic table. The synthetic table gives you 2x squared minus 3x plus 4. So as a result, this is one of your factors. I can't have another thing with 2x, because 2x times 2x would give me a 4x cubed. And we didn't have that for p of x. P of x, it was 2x cubed. So this cannot work, because if I multiply these out, see the two things I'm circling here? Let me point to it. If I had to multiply this times this, it would not get me back to the original guaranteed, because this times this alone would give me 4x cubed, which I never had in the original, in the first place. Okay? Let's do another example so you can see a little bit more of this. Okay, a little bit more of this. Let's say, I need to, let me show you a simple way to make up your own practice problems that will work well if you want to study for this, okay? Let me show you a quick method. Go to Chrome or a browser, please. If it said find all the roots of this, we're looking to see when this is set equal to 0. If it said find all of the zeros of the function, we have to also set this equal to 0. How do I solve this if I can't factor? Go right to the quadratic formula. Okay, right to the quadratic formula. What you're going to recognize, obviously, a minute ago we talked about this. Look at your discriminant. It's 1 squared minus some bigger number. That's what guaranteed these roots to be imaginary, because we made the discriminant negative by choosing A, B, and C wisely. Okay, this is a problem that we just made up. It makes sense to do it that way. So we'll end up getting, what is this going to be? Negative 1/4 plus or minus. We're going to get 1 minus, this is going to be 8, 24. 1 minus 24, so negative 23 over 4. I'm breaking up the 4 just to make it look nicer. All right, so I can leave it like that, but I really probably would want to write my roots as explicitly as possible. So since they're imaginary, we can write them like this. Okay, remembering to just rewrite the exact same answer from the previous line, but just put the I at the very end and make the radical a positive. So those are two of my roots of the function set equal to 0. Or those are two of my zeros of the function. What's the third zero of the function? It's up here. Right there, I'm circling it over and over again. Negative 2. The one that we tried that made the function equal to 0, or the y value equal to 0. So I want you to be certain that you understand that this, what we're doing right now, stems from synthetic division, but it is not synthetic division. It is synthetic substitution, where you evaluate a value to set it to 0 so that you can get the depressed equation to then solve further. It's a method to solve a cubic equation to get all of its factors or all of its roots. Or a fourth equation, or a fifth order. And we'll see those in 8-7. I'll do a lot more with those when we learn a little bit more still. Now, I want you to remember this. If I ask you to actually use synthetic division, the remainder is part of your answer, right? That remainder over here has to do with it. So let's talk about that for a quick sec. What time we got? 29?
9 minutes.
9 minutes? So if I said to you, divide 4x cubed plus 3x minus 2x squared plus 7 by x minus 4. And I want you to divide this using long division and synthetic division. Which would you probably do first? Honestly, which is easier to you? I think synthetic is easier, personally. I'd probably do that first, so I can get the remainder, so that when I do long division, I can check my work as I'm going through it. Okay, so I'd go with synthetic first. So using synthetic division to figure out what the actual quotient would be, I go ahead and I approach this the same way. Take a look at my top numbers. Did you use the same as me? Check the order. Did you do the same? 4, -2, 3, 7. Please remember that order matters. 4 comes first, as -2 comes next, +3 comes third, and then +7 comes last. What goes on the outside over here, Sarah? Why? Exactly. Remember, we try to always divide it by the quantity x minus c. This whole theory, this whole theory behind it is that we're dividing a polynomial by x minus c. So c is taken the place of by the number 4. So we're putting a 4 in, really. And this goes back to the idea that this could be a factor, right? X minus 4 could be a factor. If x minus 4 was a factor, you would use +4, because that would be the root, right? Again, go back to the last thing we just did. If x minus 4 was a factor, you'd use +4. X minus 4 could indeed be a factor. If we get 0 as a remainder, x minus 4 is a factor. And our answer is very easy. We could easily divide. There's no remainder at all. But I have a feeling that there's going to be a remainder here. Okay, so let's bring stuff down. 4 by 4 is 16. 16 minus 2 is going to give me 14. 4 by 14 is going to give me, what, 56? Plus 3 is 57. 4 by 57, 228. Oh, 59, thank you, jeez. I added 2 to it. No, let's rewrite it. 59. 4 by 59. 2 plus the 7. So what's happening here clearly? These numbers are successfully getting larger, right? We're going to talk about that in 8-7, what that means, believe it or not, as the numbers get larger. The important part is this. This is not a factor. X minus 4 is not a factor of that numerator because of the fact that the remainder is not 0. So what would my answer be, Jeff? How would I write my answer to this problem? If it said, divide the numerator by the denominator, give your answer in mixed terms or as a mixed number, as a mixed expression.
It would be 4x squared plus 14x plus 59 plus 243 x.
Very good. Good correction there, Jeff. So again, we've got the quotient, 4x squared plus 14x plus 59. I think of that as the quotient, right? The thing you got out when you divided, plus the remainder over the divisor. Right? The remainder over the divisor. So what's the y value when I plug a 4 into the numerator, if the numerator were a function? Say the numerator were a function. Look at the numerator up top. Make believe for a second that the numerator was some function, and I'm specifically just looking at it by itself. If I plug a 4 into that function, what am I going to get as a y value? 243. Well, the remainder is still the y value, even though we're not doing that topic, it still is. If I thought of the numerator as its own function and I plugged in a 4 and I get 243 out, well, here's x, comma, y. 4, comma, 243. Way, way, way beyond where we want to be, right? We're looking for roots, so we're trying to get this to be 0, really. That's our goal in this whole idea. Okay, that's synthetic division. That's how it's different. How about long division of this problem? Can we do that? 4, -2, 3, 7. And we have x minus 4 on the outside. Is that right? I'm going to go through this one step at a time because this could be a little bit tricky. What number or what expression should go up here in this box so that when I multiply it by x, right, when I take what's in that box and multiply it by x, I want to get the same thing that's here. Please look up if you're not really 100% on this topic. I want to figure out what goes here so that when I multiply it by this, I get this exact thing right here. James? 4x squared. It's because 4x squared times x is indeed 4x cubed. James, what do I do next after the 4x squared? Do I just leave it like that at 4x cubed?
You also multiply it for negative 4.
So I get negative 16x squared.
And then you put it in parentheses and put a minus sign.
And I remember I'm subtracting this whole thing. So let's go one step at a time. Hopefully we'll get the exact same answer as we have at the top here. When I subtract these, 4x cubed minus 4x cubed is indeed 0. We're going to bring down the 3x right here. We're going to bring down the 7 right here. I'm going to have negative 2x squared minus negative 16x squared minus the negative is a positive. So I really have a positive 16 and a negative 2. So a positive 14x squared. So that's what I've got now. How do I get rid of 14x squared? What do I have to multiply 14x squared by in this location? What do I have to multiply, I said that wrong, x by in this location to get 14x squared? Again, always think, what's missing here, so that when I multiply by the divisor, I get what's here. Morgan? 14x. Positive or negative? Positive. You didn't say it, that's why I asked. I wasn't trying to trick you. The reason it's positive, Morgan, remember, you want these to be identical because you're subtracting them anyway. This is positive, so you want it to remain positive, okay? So 14x times x is 14x squared. Then we take the 14x, after we multiply by the x, we also multiply by the negative 4. 14 by negative 4 is negative 56. I remember to subtract these. I keep going down. Notice the similarities between the numbers in the synthetic table and what we're getting as answers here. That 56 came up earlier, didn't it? And now we're going to get 59 as an answer here, right? You see that? Look, the 59 here is the 59 from the synthetic table. The 14 here is the 14 from the synthetic table. Does anyone see what I'm saying right now? You guys see what I'm saying here? Look, this 14 that shows up here is there. This 59 that shows up here ends up being there anyway. So we're going to see these similarities as we go through. Well, a lot of these came from when we were adding and subtracting these little rows here. Okay, we're going to get a plus 7 here at the end. And then finally, if we want to multiply something by x to get 59x, it's got to be what? 59. And when we do that, we'll get the same exact answer as we had in the beginning. We're going to have 59 times 4. That's going to give me 236. It's going to be a negative 4. I'm subtracting the whole thing. So 7 plus 236 gives me indeed 243. Okay, the exact same answer we got from the previous one. Practice tonight. Make sure you practice word problems with direct and indirect variation. We didn't even get to that. But I put examples on the practice problems, and on your quiz you have examples. There are more in the Chapter 8 test at the end. Word problems with direct, joint variation, all that stuff. Office hours right after school. Unless you have a club, let me know. Activities is also right after school today. You're welcome, ma'am. Have a good day.